Hello, Honors Chemistry, and welcome to Chapter 2. So every single chapter is going to have some of these lecture videos, so let's go over just a couple of things. So I like to assume that you read the little blurb on top of the page where you access this video, but just in case, highlights include lecture videos are lecture, right? So that means you should be seated with your outline. You should have your, I guess you could be standing if that's how you like to roll, but you should have your outline out, you should have your book, you should have something to write with. You should have a colorful pen, something different than the color you took your book notes in, right? Because what's going to happen is your outline is going to become a layer, right? There are going to be one layer of book notes, a layer of video notes, right? And then a separate layer for anything else that we happen to mention in class, okay? In addition, right, if you realize there is something, I should have written that down, push pause, go back a little bit and write it down, right? If you're still trying to process something, stop the video, right, and think about it a little bit longer, right? If there's a problem, like, so for example, I'm going to work out some of this scientific notation, right? We're going to work through some practice problems together. Stop the video, work it yourself first, right? See if you can do it. This gives you the opportunity to self-check as you go to make sure that you understand what's happening, okay? The practice problems that we work in this video are the skill builders from the unit, right? So if you found them challenging, right, then this is the place where you would get some clarification on that. If you thought all the skill builders were delightfully easy and you figured them all out, then you could probably, double time through those sections. Okay, so anyway, scientific notation, a quick refresher. If you feel like you need a little bit more help refreshing your memory on scientific notation than what I provide here, drop by and we can chat about it further, okay? So don't forget that scientific notation is simply a way to express numbers. In chemistry class, if there are more than 3 zeros, right, either 3 zeros making it big, 3 zeros making it small, if there are more than 3 zeros, you need to put it in scientific notation, which means that, yes, you need to know how to do scientific notation. So, here we have 2.5 times 10 to the 6th, right? So when we say 10 to the positive 6 versus 10 to the negative 6, what's the difference there? Right, positive 6 and all positive exponents always mean big number, right? That number is big, whereas a negative exponent means tiny, right? So tiny, in fact, that it's a decimal value, right? Negative exponents always express a decimal or less than 1 value, right? So then if we were going to translate these numbers out, right, that's the part most everybody remembers, right? We would take our 2.5, and what that means is we move 6 places bigger, right? So 1, 2, 3, 4, 5, 6, right? So 2, 5, 1, 2, 3, 4, 5 zeros, right? Whereas 2.5 times 10 to the negative 6, so 2.5, negative 6 means we go 6 places smaller, right? So 1, 2, 3, 4, 5, 6, right? And so then that becomes 1, 2, 3, 4, 5. Yes, makes sense? All right, then let's say we're going to translate these other two values into scientific notation, okay? So here, this is where the decimal is currently located. We're going to go 1, 2, 3, 4, 5, 6, right? So obviously it's 6 places, right? So 1.23 times 10, right? And the number is going to be 6, but should it be positive 6 or negative 6, and how can you be sure? Right, it's definitely going to be negative 6 because this is a decimal value. Yes, it is a small number, so what I'm trying to express in scientific notation had better reflect that I'm talking about a tiny number, right? Does that make sense? Whereas if I said 1.23 times 10 to the positive 6, I would be expressing a giant number, right? Which is why that one's not correct. So then down here, right, currently the implied decimal is here. So 1, 2, 3, 4, 5, 6, 7, 8, right? So again, 1.23 times 10, and we know that it's going to be a positive 8 to reflect that fact that this is a ginormous number. Good? Makes sense? Okay. Which then brings us into significant figures, right? Where we care, right? Sig figs is basically the level of accuracy of a number, right? Or the level, it reflects the level of precision in my measuring device, because pretty much everything we talk about is going to be a measurement of some sort, right? So looking here, we have a quarter, right? Which if we drag this down, right, comes down here-ish, right? So it would be incorrect if we decided to call this, let's say 2.123, right? So 2.300000, right? That's saying that I know the accuracy of this out to 1, 2, 3, 4, 5, 6 decimal places, right? But this measuring device does not let me know that many decimal places, so that would be inaccurate, right? That would be a lie for me to write down quite that many places. Yes, does that make sense, right? So the rule is for any measuring device, we can estimate one place beyond the smallest graduation, right? We will always estimate one place beyond the smallest graduation. So here, if we look, the smallest graduation is tenths of centimeters. So this is 3 and this is 4. And that puts us, and here, right, we have to do a little bit of eyeballing, right? So we can see that that this mark is just beyond halfway, right? So I could fairly estimate 2.36, okay? Where that place is estimated, this is the smallest graduation. Yes, does that make sense? Okay, so then likewise, if we take this here, this is 140, this is 160, which makes this 150, right? Which makes this one, what? Right, 145, which then makes all of these 1, right? So again, we will do our graduation. So 145, 146, 147. So we're at 147. And then, since 1s are the smallest graduation, we can estimate one place further, and it's clearly less than half, right? So we'll go 147.3. Yes, does that make sense? Where this is the smallest graduation, and this is the estimated place, okay? Last up, we have a thermometer, which says it's marked off in Fahrenheit, okay? So this is 90, this is 100, which makes this 110, right? So let's put that there to be clear, right? 110, which means that this is 105. So this is 1, 2, 3. That looks just under halfway. So 103.4. Yes, does that make sense, right? Where this is the smallest graduation, this is my estimated place. All right, so further, right, going to something a little bit different. So this is 5, this is 6, and if we look here, these then are what graduation? Right, those are tenths. So we're at 5, by the way. This is water, right, which exhibits a meniscus. Where do we read that? Right, we would focus in on the very bottom part of the meniscus. So we are at 5.12345, so 5.5. But then we'll see in this blow up here, right, this blow up says that there are actually teeny tiny graduations of the hundredths place on that graduated cylinder if we look very carefully, right? And this appears to be on the line, right? Which must mean that the smallest graduation is this, and then I would estimate still one place further. Yes, does that make sense? All right. Oh, and then going back to how to count significant figures, which I forgot to put here. I should have made a slide for that. So how to count significant figures. If we go back to these as a point of reference, right? Here, scientific notation is going to be super easy because whatever we've written is significant. So if I wrote 2.3000 times 10 to the 8th, right? All of that is significant. Otherwise, I wouldn't write it, okay? So that one's quick and simple. Now, in terms of zeros that are in the middle, those are always significant, right? So 205, that's significant. 2,000, and lots of zeros. All of these are significant, okay? Zeros in the middle, definitely significant. The only ones that are weird, right, the only ones that are thoughtful are ones that are either at the front of a number or the back end of a number, right? So for example here, right? How to know if all those zeros are significant or not, right? The answer is not. There are only 2 significant figures here, right? So 2 sig figs, right? Because if we think about everything as a measurement, all of these are there just to say how small the measurement is, right? The measurement doesn't begin until we get to a number. Yes, does that make sense? The measurement cannot begin until we get to a number, which is why that's 2 significant figures, okay? Likewise, this one is 3 significant figures, okay? And then if we go in the other direction, so this one, right, as written, is 2 significant figures, and these are all placeholders. because all those do is serve to tell me how big that number is without lending any accuracy, right? Which is different than if I said 25000 decimal place 00, right? Because what that means is that I measured 2 here and I kept on going, right? So this would have 1, 2, 3, 4, 5, 6, 7 sig figs, right? Due to the fact that every single one of those pieces of information is significant, right? Going back up here, let's say that I did that and I put some more zeros at the end. So now all of these are significant, right? So you'll see that the trend between here and here, right, are if zeros are after both digits and decimals, they are significant. If zeros are after both digits and decimals, they are significant, right? So let's try to apply that here, right? So these zeros come after a decimal, after some digits, which means they're significant, right? Which then means that these now become just like these, right? Such that they're in the middle of the value, which means everything there is significant. Yes, does that make sense? Whereas these zeros do not meet that criteria, right? They are not after digits and decimals, right? You might say, oh, these are after decimals, but they're still not after any digits, right? Which means only those are significant. Yes? In terms of how to count significant figures. We'll do some more practice and that will help, I'm sure. Okay. So applying some math and significant figures and putting that together, right? So obviously you've already read your section, right? So here, if we're doing multiplication and division, the rule is that we always keep the least number of sig figs, right? And the reason that is because, again, right, so here it's hard to see because we don't have any units on any of these values yet, right? But for whatever is my least precise measurement, my final answer cannot be more precise than that. Yes, does that make sense? Whatever my least precise measurement is limits the precision of my final answer, right? So we're going to look at all my numbers here. So this has how many sig figs? 3. This has how many sig figs? 3. This has 4. This has, ding, 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 1. This one has 2, right? Which means that in terms of limiting my sig figs, that's going to be it, right? So then we will go ahead and do the operations, right? So we'd multiply, 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 and divide, right? Which then gives us a final number of 0.00107753. Now again, you never ever round until the very, very end, okay? Never round until the very end. So now we have our final number, right? We know we have to round to one significant figure. So what we're going to do is we're going to look, right? So again, these zeros don't count yet. Here's our first value. And then we're going to use that 0 next to it. Does that number have to change? No. So 0.001 is our final answer. Or we could say 1 times 10 to the negative third is our final answer. Yeah, makes sense? Okay. Next up, let's go ahead and count our sig figs, right? Okay, so 4.562 has 4 sig figs. This one has 6 sig figs. And this one has 3, right? Which means 3 is going to be my limiting number of significant figures. So we would go ahead and do all of our math operations, rounding at the very end. So we'll go ahead and write down our whole number. And you should make that your habit. You should always go ahead and write down the whole number your calculator spits out, okay? Or a very long version of it, right? That covers more sig figs than we'll definitely need. And then, so that shows me, right, by writing this number down, that shows me you know how to do math, okay? Then the next step is the rounding to the proper number of significant figures. So if you have this value and the only thing you do wrong is write down the wrong number of sig figs, right? That is one small deduction. Whereas if you just do a terrible number and write a really bad rounding number here, I'm not sure if you've made a math error or just a rounding error. So that's going to be a bigger deduction, right? Does that make sense? Okay, so just my personal opinion. Okay, so we need 3 significant figures, right? So we're going to go ahead and count them, right? So that's 1, 2, 3. That's an 8, so that's going to become a 4. So 0.204 is my final answer. Yes? Okay. Now coming down here, when we add and subtract, we are going to keep the least number of decimal places, right? again, going back to the fact that the level of precision in my number matters, right? Where decimals are the precision when we're adding and subtracting, right? So if we take our numbers here, this one has 2 decimal places, 3, 4, 1. So our final answer can have 1 decimal place. So we'll go ahead and do that math, which says 7.588. We can only have 1 decimal place, so this becomes 7.6 as a final answer. All right. Over here, right, we have 3, 2, 3, which means we're going to write down our final answer. And we're going to cut it to 2 decimal places. So again, 131.11, right? So do be mindful, right, that it can be confusing, right? Because this one I feel like is easy, right? Least number of sig figs when we multiply and divide. Something about least number of decimals just gets a little bit more thoughtful, right? Because you want to think about the total number of sig figs, but that's not what we're talking about when we do addition and subtraction. So obviously when we do mixed math, we're going to have to think about all of those, but the same principle applies that we will not round until the very end, right? So following correct order of operations, which I can't emphasize enough, if need be, go refresh order of operations, because as our math problems get bigger and bigger, it becomes a bigger and bigger issue. But so first we'll do the subtraction step, and then we'll go ahead and do the multiplication step, which gets us a value of 1287.6467, right? And then we have to think. So when we do this subtraction step, what's the limiting number of sig figs? Or what's the limiting thing to think about in terms of sig figs? Right, 1 decimal place. 1 decimal place is the thing to think about, right? So when we do that subtraction, 1 decimal place is actually going to get us 4 sig figs, right? Does that make sense? 1 decimal place is going to get us 4 sig figs. And here it might help to come up with that number, right? So if I take 782.3 and I subtract 451.88, I get 330.42, yes? Which, if I keep 1 decimal, is 4 sig figs. Yeah, do you see that? Okay. And then this one has 4 sig figs, which means I'm going to cut this to 4 sig figs. So 1288 is my final answer. Down here, we'll do the same analysis, right? We'll do this division step, right? Where 3 is going to be my limiting number of sig figs, and then I'm going to subtract, and this is going to be 3 decimal places, right? So 3 decimal places versus 3 sig figs, right? Well, so here, let's go ahead and do this, right? So this intermediate value is 3.6965, etc., right? This final answer is 3.1185, right? So, again, 3 sig figs. This one is 3 decimal places. 3 sig figs is only 2 decimal places, yes? Do you see? Which means that we are going to now cut this to 2 decimal places, which is going to be 3.12. Yes? All right, look those over, make sure they make sense. We will pick up in the next video with adding some units onto all these values. All right, thanks for listening. Be good, and I'll see you soon. Bye.